Hello students, today we are going to solve chemical kinetic questions from NEET question paper, and this exam was held on 10/6/2023. So quickly let us begin with solving chemical kinetics questions. Yes, here is our first question. Question number 163. A reaction takes place in 3 steps. The rate constants are K1, K2, K3. The overall rate constant K they have given K1, K3 by K2. If E1, E2, E3 are the activation energies of respective 3 reactions, that is to be 60, 30 and 10 kilojoules respectively, the overall energy of activation is. So this is a very simple reaction since they have actually given the rate constant, overall rate constant. So what is the overall rate constant they are giving? So which means that K is equal to, they are giving K1, K3 by K2. So which means that you need to just add the activation energies corresponding to K1. So what is the activation energy corresponding to K1? So that is nothing but 60 plus K3 is how much? 10 kilojoules minus you have to do K2's activation energy, which is nothing but 30. So which means that 70 minus 30, which is equal to 40 kilojoules is your answer. So option A is correct. So option A is correct. Now coming to the next question. In the presence of acid, the initial concentration of cane sugar was reduced from 0.2 molar to 0.1 in 5 hours and to 0.05 in 10 hours. The reaction must be off. Okay, once again, simple question. Now let us finish off this solution. So what they are saying, let us write it in. So 0.2 molar to how much it is becoming? So it is becoming 0.1, which means that there is reduction, that is concentration, that is 0.2 to 0.1 means it is becoming completely half of it. So hence the time which they have given here, that is 5 hours, can be assumed to be T half. Correct. Now what they are saying, once again from here to here, when there is formation or reduction in the concentration to 0.05, so the total time it is consumed, they are saying it is 10 hours. So which means that once again here 0.1 to 0.05. So once again half of the concentration of 0.1 is 0.05. So hence it is also once again 5 hours. So we know that according to the expression, that is T half is directly proportional to A power 1 minus n. We know that in case of first order reaction, T half is independent. Okay, T half is independent of the concentration. So hence, what does it mean? So whether you take 0.2 molar to 0.1, if it is becoming half also, it is taking 5 hours only. And now even assuming 0.1 to once again half of its concentration is also taking 5 hours, then so this is in relationship with between the first order T half, which is independent of concentration of initial concentration. So hence the option B is correct. Now coming to the 165th question. What is it? A catalyst. So about catalyst, what they are giving, increases the free energy change in the reaction, decreases the free energy change in the reaction, does not increase or decrease the free energy change in the reaction, can either increase or decrease the free energy change depending on what catalyst we use. See, basically, we have understood that catalyst is nothing but It is a substance which can just enhances the rate of the reaction without changing the extent of the reaction, and also it will not affect the free energy. So basing on that concept, option A and option B are completely wrong, and similarly option D is also wrong, and option C is correct, where they are saying that does not increase or decrease the free energy change of the reaction, because catalyst can just enhances the rate of the reaction by taking up the different mechanism by which it requires little less of the activation energy, but otherwise it doesn't change the free energy of the reaction. So option C is correct. Now coming to 166th question. For an exothermic chemical process occurring two steps. Okay. So here they are giving two steps. Basically, exothermic means the reactant's energy should be higher than product's energy, or otherwise product's energy need to be less. So, all the graphs are corresponding to exothermic only, but then the exothermic chemical process, it is occurring in two steps. First step, A plus B is giving rise to X and X is giving rise to AB. Now, if you carefully notice here, the first step is said to be slow and the second step is said to be fast. And we know a relationship here. What is that relationship? So when activation energy is high, then the rate of the reaction is less. When activation energy is less, the rate of the reaction is more. Correct? So this we have already learned. Now, basing on the two steps, since the reaction is taking place in the two steps, the first graph we can basically rule out. Why we can rule out the first option? Because it is clear that for the formation of X, there should be one transition state obtained, and for formation of AB, there should be second transition state. In this graph, only one transition state is shown, and hence option A is wrong. Now looking into B and C, so in this case, here also one transition state they are showing, and here also one transition state. So together there are two transition states, here also two transition states. Then among B and C, we need to find out which option would be correct. But based on the speed of the reaction, it is clearly evident that for the formation of the first transition state, the activation energy should be high. So activation energy of the for the formation of the first transition state to further decompose to the product X must be high, and for the formation of AB, this transition state would be taking less amounts of the activation energy. So hence option B would be correct, whereas option C would be wrong. Why? In case of option C, they are saying activation energy for the formation of X is less, whereas activation energy for the formation of AB is more. But then here they have clearly shown for the formation of X, it is slow reaction. For the formation of AB, it is a fast reaction. So hence B option is correct. Now coming to the 167th question. So what is 167th question? So they are saying that a catalyst decreases activation energy from 100 kilojoules per mole to 80 kilojoules per mole. At what temperature the rate of the reaction in the absence of catalyst at 500 Kelvin will be equal to the rate rate of the reaction in the presence of the catalyst. So it is once again quite simple. So what are we going to do? So we will be writing Arrhenius equation, because this question is based on Arrhenius equation. So what is Arrhenius equation? K is equal to A e to the power minus EA by RT. RT. Okay. So let me write it little neatly. So what is it? Minus EA by RT. Now, since they are assuming in one reaction activation energy is 100 kilojoules, the same reaction in the presence of the activation energy, it is becoming, in the presence of catalyst, the activation energy is becoming 80 kilojoules. So hence, we need to write two expressions. Let us assume this is to be K1 and K2 we will write. Let us assume this is in the absence of So this is absence of catalyst. And next, one more equation you can write, where K2 is equal to EA by RT to be presence of catalyst. Okay, in the presence of catalyst. Okay, catalyst. Now, what information they have given? So they are saying at what temperature K1 and K2 becomes equal to each other. So at what temperature K1 is becoming equal to K2. Now substituting the values, let us substitute A e to the power minus EA. Without catalyst, you have minus 100 kilojoules, okay, divided by R, and temperature is 500. Temperature is 500. So which is equal to A e to the power minus 80 kilojoules. This is in the presence of catalyst by R and T. So this temperature we are supposed to find out. Now what will happen basically? So this A and this A will get cancelled, and you will get e power minus 100 by 500 R is equal to e power minus 80 by RT. Okay. Now what will you do? Apply log on both the sides. So if you apply log on both the sides, what will you get basically? So you will get, and before this step only would have applied, but still it is okay. So you will get 100 by 500 R is equal to 80 by RT. Okay. Now what will happen? Do the cross multiplication, simple cross multiplication, or bring the like terms on the same side. So hence it will become 100 by 80, which is equal to 500 R by RT. So universal gas constant and gas constant gets cancelled, and here 100 T will become equal to 500 into 80, and T will become equal to 500 into 80 by 100. So which is equal to 400 Kelvin. So which option is correct? So option A is correct. So what they are saying, when the temperature is equal to 400 Kelvin, so both the K1 and K2 will become equal. So that is what is the option, which is nothing but 167. Option A is correct. Now coming to 168 question. So before which, let me also erase little part of this. Okay, two reactions they are giving. So what is this two reactions? A is giving rise to products and B is giving rise to products. Okay, have rate constants K and Kb at temperature T, and activation energies EA and EB respectively, if K is greater than Kb and K is less than Kb. Okay, so this would have been EA is less than EB. It cannot be once again Ka is less than. So there is a correction here in this question. It must be EA, okay, is less than EB. Then it is correct in terms of the question. So what they wanted to say, Ka, when it is greater, obviously activation energy of that reaction would be lesser, obvious. Then Kb is less, that is the rate of the reaction is less. In that case, activation energy is more. So this is in accordance with the concept of activation energy and the rate of the reaction. Okay. Now what they are basically asking, four different options they have given. Now let us go by one. So at higher temperatures, Ka will be greater than Kb. Already Ka is having lesser activation energy. When you are increasing the temperature, yes, there is chances of, increasing in the rate than Kb, and hence Ka, rate of the first reaction, will be higher when compared to Kb. So, which means that option A will be correct. Now, coming to option B. What is option B? At lower temperature, Ka and Kb will be different, will differ more, and Ka will be greater than Kb. Exactly. So this statement will also become correct. Why? Because at lower temperatures, basically what will happen? For Kb, already activation energy is very, very high, isn't it? So at lower temperature, what basically happens? So Kb value will be keep on decreasing, which means that the Kb value, rate of the second reaction, will be decreasing. In such cases, the difference between Ka and Kb will be greater than, which means that Ka will be greater than Kb only, even at lower temperature too. Okay, now what is the option C? As temperature rises, Ka and Kb will be close to each other in magnitude. Yes, of course, at a, at a point where the temperature at which there is chances of becoming Ka and Kb values to be, like, equal in magnitudes, and hence this possibility is also there. So after that, the option D they have given, all of these are correct. And obviously all the three statements are correct pertaining to the question, that is given statement Ka is greater than Kb and Ea is less than Eb, and hence option D is correct. Option D is correct. Now coming to 169th question. So what is this 169th question, students? So they are telling benzene diazonium chloride in aqueous solution decomposes as, okay, diazonium chloride and water. So this is in aqueous state. Water is also in aqueous state, that is solution, and there is formation of phenol, aqueous. So nitrogen, only gas, and HCl is once again aqueous. Okay, what they are basically asking, the reaction follows first order kinetics. If PT, so if what they are saying, if PT is the pressure of N2 at constant volume and temperature corresponding to different intervals of time T and PF after the completion of the reaction. So after the completion of the reaction, that is final pressure. PF represents here final pressure. Then which of the following graphs confirms to the kinetics of the reaction? So what hint they have given here? The hint is first order kinetics, and also they are giving two terms here. One is PF and one is PT, another one is PF. Now let us try to understand what is this PT and what is this PF and what happens. So before that, we all of us know what is the first order integrated rate expression. So where K is equal to 2.303 by T log of A divided by A minus X. So what is A basically? A is initial concentration and X is the concentration of the product that is obtained when time is equal to T. When time is equal to T, correct? No? So for this reaction, in terms of hypothetical way, I can assume this to be A plus B aqueous state, which is giving rise to A, B, C, where N2 only is gas, right? So, or otherwise, I can also directly tell you, see what happens basically, initial concentration. What is A? So, initial concentration A will be directly proportional to the final pressure, isn't it? Why it becomes final pressure? Because there is only one gaseous product, N2 is obtained, and hence whatever the diazonium chloride is there, that is completely converted into nitrogen, correct? Only in case of diazonium chloride, you have N double bond N, that is azo group, and that is converted to nitro. So now the initial concentration of this diazonium chloride should be directly proportional to PF. So what is PF? That is final pressure of the nitrogen gas that is produced. Okay. Now what will happen? Now we also have to understand what is this X and what is this A minus X. Now try to understand X. So basically when we are writing a hypothetical reaction, assume A is giving rise to products. When T is equal to 0, concentration A we will assume. When T is equal to T, there will be formation of X moles of product. No. So if X moles of product is obtained, there will be A minus X moles of reactant left at time T. Correct? Now we need to express X in terms of water. Correct? Now X, that is amount of X will be formed, will be directly proportional to PT. Why it will be directly proportional to PT? So PT is the total pressure at time T, at time T. So here total pressure is because of only N2, and hence X will be directly proportional to PT. Now assuming, and after getting the values for A and X, we can express this equation in terms of PF and PT. So how do we express? So we can express K is equal to 2.303 divided by T. So log A is how much? Directly proportional to PF. So PF divided by, once again, PF minus PT. PF minus PT. Now, we will bring this equation in terms of line regression formula so that we can compare all these four, graphs, whichever the graph would be correct. So hence, what I will do, so I'm taking T from denominator to the this side. So hence it will become this entire term I'm taking, basically this entire term. So this entire term I'm going to take it on the K side. So hence what it will become? So it will become KT divided by 2.303, okay, is equal to log PF minus log PF minus PT. Okay. So this is what I will get, right? This is what I will get it, right? Now, basically, the graph is shown between log PF minus PT only in all the cases. That is 3 cases. And in this case, it is PF minus PT versus time. And these cases, it is in terms of log PF minus PT. So hence, in terms of this, if we want to express, we will take this log PF on the other side. So it will become what? So it will become log PF minus PT, which is equal to log PF minus K by 2.303 2.303 into 1 divided by T. 1 divided by T. Now look at this. So this is basically looking like Y is equal to MX. I'm sorry. KT, here it is product of this, no? So I will write it as T. So it is not 1 by T. So basically it is T, correct? Because it is product, no? KT. So here it is T. It is T, okay? Now, on the y-axis, you will see log PF minus PT. So hence, first option is ruled out. So among D, C, D, one of the options are correct. Now, log on the y-axis, log PF minus PT is taken. And then on the x-axis, T is taken, which means that the slope, we have a negative slope. So negative slope means the line has to, pass like this, which means that there is decreasing, isn't it? So hence, this option with the intercept will be showing it as log PF. So which option is correct, students? Only log C would be correct. So hence, for 169th question, it is log C. Now coming to 170th question. So what is this 170th question, students? So once again, here they are telling, consider the reaction, this one, and importantly here we need to note that delta H value. So what is delta H value? It is minus 15 kilocalories. The energy of activation of backward reaction is, they are giving 20 kilocalories per mole. In the presence of the catalyst, energy of activation of forward they are giving. Okay, energy of activation of the forward reaction is 3 kilocalories per mole. At 400 Kelvin, the catalyst causes the rate of the reaction to increase by how many number of times they are asking in terms of exponential values, that is e power values we need to prove here. So now, before doing this question, we also have to find out what would be the activation energy of a forward reaction. What would be the activation energy of a forward reaction in the absence of catalyst? So for that, we will be using the information of delta H is equal to minus 15 Kelvin. So, and then backward reaction is 20 minus 15 kilocalories and 20 kilocalories per mole. We will be using this information and we will be finding the amount of activation energy. Okay. Now let us begin solving this question. So how do we do? First of all, let us make the graph. Okay. So I'm going to make exothermic reaction based on the value of, based on the value of delta H. So delta H is what? The energy difference between the reactants as well as products. How much is this given? 15. Okay. Kilo calories they have given, and the backward reaction, how much they are given? This is the backward reaction, which is the value of 20. Okay, 20 kilocalories per mole they have given. Now, what is our intention? Our intention is to find out what is the activation energy for a forward reaction. So obviously it will become 20 minus 50, which will become 5. So this is for the reaction in which there is no catalyst used. Now once again they are using the catalyst, and now when catalyst is used, basically we all know that when catalyst is used, what will happen? It will change the mechanism in such a way that the mechanism will require only less amount of the activation. So how much is this activation? This activation energy in the presence of the catalyst is 3 kilocalories per mole. Now what we are supposed to do it? So we need to write the Arrhenius equation. That is 2 equations we are supposed to write. One equation for in the presence of the catalyst, the other equation in the absence of the catalyst. Here I'm going to take K1 is equal to A e to the power minus EA by RT to be in the absence of the catalyst, absence of catalyst. Now second equation, so since I'm writing this is absence, so I can write it as EA1. So I can make it as EA1. Now I'm going to write it for K2. So K2 is what? So K2 is going to be for activation energy EA2 by RT in the presence of catalyst. Okay. So presence of catalyst. In the presence of catalyst. Okay. Now what we need to prove? So how many times does the rate increases, isn't it? So at temperature 400 kelvins. Okay. So which means that in the presence of the catalyst, energy of activation of forward reaction is 3 kilocalories per mole. At 400 Kelvin, the catalyst causes the rate of the reaction to increase by the number of times equal to. So how many number of times will it be equal? So hence what I'm going to do, so I'm going to divide equation 2 by equation 1. Equation 2 by equation 1. So hence it will become K2 by K1, which is equal to, since Arrhenius, that is pre-exponential factor is same for both the cases, so we can actually cancel it off. So K2 is EA2 divided by RT divided by A e to the power minus EA by EA1 by RT. What will happen? A and A gets cancelled. Now we will write K2 divided by K2 divided by K1, which is equal to e to the power minus EA, instead of e to the power minus EA2, we can also write EA1 minus EA2. Okay, I will directly write it in terms of that. So hence, it will become what? EA1 minus EA2 divided by RT. Okay, now we know the values. So what values we are aware of? So K2 by K1, which is equal to e to the power of EA1 is what? EA1 is absence of catalyst. So what is the value of activation energy of a forward reaction? That is 5 minus EA2 is activation energy in the presence of the catalyst of a forward reaction. So it will become 5 minus 3 divided by rate constant, universal gas constant, I'm sorry, universal gas constant in kilocalories. It can be taken as 2 into temperature is how much? So temperature is how much? It is 400 Kelvin. Okay, they have given 400 Kelvin. Now what it will become basically? So it will become e power 2, the difference. Okay, that is 2 into 400. Okay, which is equal to e power 2.5. Why it will become 2.5? Because this is given in terms of kilocalories. So hence you can also write it like this: e power 2 into 1000 divided by 2 into 400. So now you would understand. So how much it is? 2 and 2 gets cancelled, and 10 by 4 is equal to e power 2.5. So this is the value. So which option would be correct? So option B is correct for 170th question. Okay. Now let us take up the next question. What is the next question? If K1 is equal to rate constant and temperature T1 and K2 is equal to rate constant and temperature T2 for a first order reaction, then which of the following relations is correct? So EA is the activation energy. So it is quite simple. So basically we know that log K2 by K1 is equal to EA by 2.303 or T2 minus T1 by T1 into T2. Correct, no? So hence option B only is correct, whereas option A, they have taken K1 by K2 and 2.303 EA on the numerator, the value of 2.303, that won't come. So basically it is option B only is correct. So if we have to derive it, we need to just take two K1 and K2 values for two Arrhenius equations, and if you do it, you will be getting the formula which is close to option B. That is the formula. Which one will be correct? So option B will be correct, which is nothing but log K2 by K1 is equal to EA by 2.303 T2 minus T1 divided by T1 into T2. Okay, so this is a direct question. So coming to 172, for the two gaseous reaction, following data are given. So, okay, K1 and K2 in terms of Arrhenius equation they have given. The temperature at which K1 becomes equal to K2. Okay, so K1 and K2 is given. At what temperature basically K1 and K2 becomes equal to each other is the question. So basically we need to equate these two. Okay, these two values we need to equate. So let us now start do the equating. So 10 power 10 e power minus 20,000 divided by t should be equated here as 10 power 12 e power minus how much? 24,606 divided by temperature. Okay, why are we equating this? Because they are asking at what temperature K1 is becoming equal to K2. So to solve this, we need to equate these two values. Now what I will do? So I will bring the like terms on the same side. So if I bring this 10 power 2 here on the right hand side and this value on the left hand side. So what will happen basically? You will get e power so what I'm planning 10 power 12 divided by okay 10 power 12 divided by 10 power 10. If you do it, what will happen? You will get e power minus 20 thousands by t divided by e power minus 24,606 divided by t. Okay. Now, if you simplify this term, you will get it as e power minus 24,606. It becomes positive divided by, okay, let me do it in, apply log on both the sides. So if you apply log on both the sides, what will you get basically? So you will get this value to be, I will write 10 power 2 will be equal to e power 24,606 minus 20,000 divided by t. You will get it. Now applying log. So when you apply log, it will become 2 log 10 is equal to 24,606. The difference is how much? So directly we will take the difference. So what is the difference? 4,606, right? So you will get here 4,606 divided by 2.303 t. You will get it. Okay. Now 2 log 10 is nothing but just 2 value only, because log 10 is 1. So 2 is equal to 4606 divided by 2.303 t. So when you take t on the other side, it will become t is equal to 1000 Kelvin. So which option is correct, students? So option B is correct. So what does it mean? So at 1000 kelvins, basically K1 and K2 will become equal to each other. So that is what is the meaning of 172nd question. 172nd question. Now we will take up the next question. Okay, what is the next question? According to Arrhenius equation, a straight line is to be obtained by plotting the logarithm of constant of a chemical reaction log K against. Okay, friends. So this question is once again very simple. We will just write what is Arrhenius equation. So K is equal to A e to the power minus EA by RT. Apply log on both the sides. If you apply log on both the sides, it will become log K is equal to log A minus EA by R, that is 2.303 R. It will become 2.303 R into 1 by temperature. Okay. Now basically this looks like the line regression formula, that is y is equal to, this is mx c. Okay, slope is negative and hence you will get a negative line, that is you will get a down line that is decreasing. So which means that which option is correct? Is it T? No, log K versus 1 by T only you will get a graph where there is a negative slope. So which means that which option is correct, students? Option C is correct. Now coming to the next reaction. If for any reaction the rate constant is equal to the rate of the reaction at all concentrations. So once again it is easy. I have told you several times that it must be the zero order reaction where zero order reaction rate constant K as well as the rate of the reaction will be always same. It will have always the same units. So hence option A is correct. Now coming to 175th question. If a reaction A plus B is giving rise to C is exothermic to the extent of 30 kilojoules per mole and forward reaction has an activation energy of 70 kilojoules per mole, the activation energy for the reverse of the reaction. So fine, they are giving the hint here. So what is the hint here? So hint is nothing but the exothermic reaction. Now exothermic means we basically remember how to make the graph. So how to make the graph? So graph, we all of us know that if you are making a graph like this, so we know the energy of the redo. Okay, this is energy of the reactants and this is the energy of the products. Okay, these are reactants. What they are giving? Exothermic to the extent of, andre what they have given? So they have given delta H value. So what is delta H value? The differences in the energy of the reactants as well as energy of the products is what is called the energy of the reaction, which is called delta H. So what is delta H? They are giving 30 kilojoules. 30 kilojoules. Now what they are giving? And the forward reaction has activation energy. So what is forward reaction? So from here, right? So this is what is the forward reaction, which is given to be 70 kilojoules. Now they are asking for the reverse of the activation energy for the reverse of the reaction, that is products to reactants. If you have to show, then the total will become 70 plus 30, which is equal to 100. So option D would be correct. Option D would be correct. Now just look into the 176 question. For a reaction for which the activation energies of forward and reverse directions are equal in value, then which option is correct, they are asking. Okay, so what they are saying here? So they are saying that the activation energy of forward and reverse directions are equal, it seems. What will happen basically? So we know the formula. So what is that formula? So we have the formula, which is nothing but delta H is equal to EAF minus EAB, forward minus backward. Correct? Now what they are saying? So this value and this value is same, it seems. Same means it will become 0. Delta H value will become 0. So option B is correct. Okay. Now coming to 177th question. What is 177? Which statement is true about the half-life of a first order reaction? First of all, let us write T half of nth order reaction. So what is T half of nth order reaction? Is directly proportional to a power 1 minus n. So they are asking for first order. So first order means what? So a power 1 minus 1, n is equal to 1 means 1 minus 1 becomes 0, and hence T half will become equal to, so T half is directly proportional to a power 0, which is nothing but T half is independent of, T half is independent of A. Independent of what? So initial concentration, that is A. So this is what we have understood from T half of nth order reaction. What they are giving? A larger rate constant corresponds to a longer half-life. So how this is going to be, correct? Because they are saying larger rate constant corresponds to longer half-life. So we know once again T half formula of first order reaction. What is it? T half is basically is equal to, okay, equal it is T half is equal to what it is basically 0.693 by K. So they are talking about rate constant. If we have a large rate constant, what will happen basically? T half should be decreased because these two are inversely related. So hence option A is wrong. So what they wanted to pick, which is true. So we need to pick the statement which is true about the first order half-life of a first order. Okay, then option A is wrong. The half-life is directly proportional to the original concentration of the reactant. Where original concentration? It is independent of A, and hence option B is also wrong. The half-life is directly proportional to the final concentration of the reactant. Of course, it is not true. So D option is what? The half-life is inversely proportional to the rate constant. So hence T half is inversely proportional to rate constant, and option B only would be the correct option. Now coming to the 178th question. So what is 178th question? So 178th question, they are saying that, let me take 2A plus B is giving rise to A to B. If the volume of the vessel is quickly reduced to half of its original volume. See, whenever we reduce the volume, the rate of the reaction has to increase because volume is reduced for gaseous reactants, and hence all the reactants will come close to each other, and hence the rate need to increase basically. And one more hint they are giving here is it is elementary reaction. So what do you mean by elementary reaction? For an elementary reaction, you can give the rate law directly. So how can you give rate law directly? So rate is equal to K into A, which is raised to the power 2 because stoichiometric coefficient, and which will be multiplied with concentration of heat. Now what they are saying, if the volume is quickly reduced to half of its original volume, so assuming this to be original volume, now we will be given rate for reduction in the volume. What will happen? The concentration will become double. Concentration of A will become double, and this will also become double. So now what will happen? So it will become 4 into 2, which means that 8 times the rate will increase. 8 times the rate will increase, because here if you take it as 1 square and 1, it will become only 1. Whereas when you by decreasing the volume of the vessel to half, so concentration is increasing, and hence the rate will also increase, and this will increase by 8 times. Okay. Now the last question. Which of the following is incorrect? So what they are giving? So for the first order reaction, T99 is equal to 2 into T90. Absolutely correct. Then average life. So what is average life, students? So average life is indicated with the symbol tau. Tau is equal to 1.44 into T half, no? correct? So this is the equation, but here what they have given, 1.44 into 1 by k now. So basically, we will also express tau value as 1 by k, but in terms of t half means only when we will be using 1.44 into t half. So hence, option B is wrong. Let us look into C and D also. For first order reaction, P 99.9% is equal to 10 into T half. So once again, this is also correct, 10 into T half. And D option is what? For second order reaction, T half is inversely proportional to initial concentration of the reactant. So this is also correct. So hence, which option is wrong? So option B only is wrong in case of 180th question. So hence, we have solved all the questions from chemical kinetics. If you have any doubts or queries, you can approach me during our classes. So thank you, students.